Okay. I'm looking as everybody jumps in.
So you're doing a different NQP group this time, Sarah.
One from the same group and one from a
I
different
just see
group.
Daniel saying,
Yeah.
you are frozen.
You're not frozen for us.
No, I know. Well,
Yeah.
here, I will.
I mean, you're frozen, but your mouth is wide open. I can count your cavities.
Oh gosh. Oh, I see Daniel.
Hey,
in
Kelly.
the remote to panelist. Daniel was in the attendee.
Oh, perfect.
That should have worked. Awesome. Well, since we are on the, or we're 1 minute over now, but that's completely fine. Hello, everyone. Welcome to one of our open house / virtual information sessions about our academic department for mechanical engineering. So we are so happy to be able to have some of the folks from the mechanical engineering department here. And I'll introduce myself and then I'll hand it off to them so they can go into their thing. I guess real quick before we start, some quick housekeeping items that this is a Zoom webinar format. So you can see us, but we cannot see you, and the chat feature is turned off. So please feel free to use the Q&A feature for any questions that you have throughout the presentation. And we'll make sure, I'll be there at the end to make sure that we can go ahead and get all of the questions answered. I'll facilitate. So anyway, my name is Liz DeRozier. I use she, her pronouns. I've been at WPI for about 7 years in the admissions office, and I am thrilled to be here today. I love seeing these presentations and learning more about each department every year. So that's a little bit about me, and I'm going to hand it off to Sarah, and she is going to get us started here, and I'll see you guys in a bit.
All right. Hopefully I am sharing the correct screen. I think I am. Wonderful. Hello, everyone. I'm Professor Sarah Woden Schwartz. I'm an associate professor of teaching in mechanical engineering, and I'm joined today by our associate department head, Professor John Sullivan, and two of our fantastic senior students in mechanical engineering, Kelly and Dan. And so we're going to talk a little bit about the department first, and then we're going to open things up for you all to ask questions. Feel free to use the Q&A tab and ask your questions as we're going through things. And we can be typing answers to you, or if they seem more appropriate, we'll answer them live. Yeah, so mechanical engineering at WPI. There we go. So you might be thinking, why mechanical engineering as you're starting out, you're looking at colleges. And so we like to say in our department that the world depends on ME. It's a really exciting and very broad field, which makes it very appealing. It was ranked the number 7 among the best technology jobs, and it has a very low unemployment rate. So those are a few reasons to think about mechanical engineering. Some of the types of things that you deal with mechanical engineering, there's a lot of stuff, making stuff, figuring out how stuff works to help people. Here we have a quote from Theodore von Karman that says, "Scientists discover the world that exists and engineers create the world that never was." And so working on power systems, things like different engines or alternative energy systems. Here we have a really creative and interesting gearing system. So you're spinning this triangularly shaped gear inside this rounded rectangular housing. So lots of really interesting things. And if you're into mechanical things and how things work, mechanical engineering might be for you. Mechanical engineering is probably the most popular still. This is from 2018, but it is the most popular major of all of the engineerings. You can see there's a lot of stuff happening in this graphic, but the important thing to note is ME right across the top, staying number 1 the whole time. We're very popular. RBE, which is similar in many ways to ME and a very common double major that students do between ME and RBE, has been climbing through the ranks over the past couple of years as well. So you probably are also thinking maybe why WPI might be a good fit for you. We have a lot of great rankings for WPI. It was listed as one of the country's best, most interesting colleges and universities. We also have really high starting salaries for our graduates, as well as really high rankings for the past 5 consecutive years in terms of salary. We also have a really high retention for our first year class. So if you get into WPI, we really want you to be able to be successful here and to stay here. And you can see we have retention rates in the mid to upper 90s for our first year class retained into their second year at WPI, which is really quite high. We really want you to succeed here. And we do everything we can to make that happen. And so mechanical engineering at WPI, we're really big on combining theory with practice. So students learn both theory and they do practice in the classroom, in their project work. They work on teams, both with engineers and other majors. And again, we have this big project-based education. And so those can be projects in your courses. They can be the bigger project experiences that you will have available to you every year while you're at WPI. Using this, the new WPI plan, it's really given us the chance to have students work more deeply on their project work throughout their time here at WPI. So in mechanical engineering, just engineering mechanical specifically, we have the undergraduate degree of mechanical engineering, but our department also offers graduate degrees in master's and PhD in mechanical, materials science engineering, and manufacturing engineering. And some of this can be rolled into our BS MS program that Professor Sullivan is going to talk a little bit about in a bit. But before we do, I'm going to pass it over to Professor Sullivan to talk a little bit about the courses and the makeup of your curriculum if you choose to come to WPI.
Hi, everybody. I really do hope that you get an opportunity to come to WPI. It is a very fun place. One of the real features about mechanical engineering that we have is that virtually 50% of all the courses that you take in your engineering 4-year career at WPI are going to be courses that you choose. For mechanical engineering, you need to solve or complete 18 courses or course equivalents in order to get your degree in mechanical engineering. We require that you take 9 of those courses. So we require that one STEM be a mechanical STEM. It includes the statics, the stress, and the dynamics. The statics, what are the loads that each member is sustaining, such as a chair that somebody might be sitting on. The stress would be how much would each of the legs be compressing due to the weight of the person sitting on the chair, as well as the material properties. And then the dynamics, when you are having things in motion, what happens with that. But once you have those 3 courses, we believe that you've got a solid underpinning in the mechanical components of your engineering education. We also require an energy component too. That energy component has thermodynamics, fluid flow, and heat transfer. So for example, your thermodynamics, you would figure out how much energy is stored in given materials, liquids, for example. You wish to take a shower, but you're living on the 5th floor in a dorm. How much pressure do you need in order to pump that water up to the 5th floor? And then you want the shower to be hot. So therefore, you've got the heat transfer aspects that'll ride on top of your fluid flow in order to get a nice hot shower. But this gives you the basic energy components that you would have for mechanical engineering. And we also require that you are exposed fairly well to material science for introduction to materials. Also, electrical engineering. You'll need to take a course in that. and engineering experimentation. How do I make measurements? How do I record them? How do I determine what their accuracies are? But once you have these 9 courses, that's it. You've satisfied all the required courses. The other 9 courses or their equivalents are up to you. If you really like the mechanics, then maybe you'll take kinematics, design of machines, mechatronics, advanced engineering design. If you like energy, maybe you want renewable energy, integrated thermal mechanical systems, thermal system designs. Or if you're into materials or electrical properties, we offer a slurry of courses in that area too. Another feature that we do offer is a combined BS-MS program. That combined BS-MS program, it allows you to take up to 12 credits of graduate courses while you're an undergraduate and count them toward your undergraduate degree and toward your graduate degree. And in doing that, you can complete a combine bachelor's and master's in a much more accelerated pace. As we take a look at our engineering requirements that we have here, you can see that we've got the mechanical systems, the thermal systems, and the other courses, which is again our experimentation, our electrical engineering and things. But when you satisfy those, you are ready in order to graduate. As we've already talked about, one of the main features about WPI is the project-based education. And we have 4 years, 4 major projects, but we frequently get questions. And yes, many of our design courses and even our engineering science courses, they also involve many projects that you would do within that course. So if you look at our major qualifying project, basically your senior project that you would do, many of them span a lot of different areas. In the upper left-hand corner, you can kind of see a dragonfly robot. What happens when you're trying to add soft robotics onto a mechanical system in order to get motion? Or the upper right, you've got somebody acting as an android, working out various types of motions. But beyond these mechanical systems, you've got, let's say, the lower center is a energy related system. And here you have somebody who is a paraplegic or a quadriplegic, and they wind up sitting for long hours, which can create bed sores. The students designed a seat cushion that when the person sits on that seat cushion, their body temperature heats that seat cushion, but the cushion is made out of a combined ammonia and water mixture such that it boils at about body basal temperature, which means that you will be extracting heat from the body. You will be cooling the body off in order to cause this boiling to occur. But when this, ammonia vapor mixture does boil, it will turn to vapor, and then the vapor will rise because vapors rise compared to liquid. And it will go outside of your immediate body area, and it'll get into room temperature, and it will condense. It will turn back into liquid, and then it will flow down, shall we say, the red tubes that we have in that figure. So what you get is an automatic cooler that reduces your body heat. It cools you, it has no moving parts, it has no batteries. It just works. But that's mechanical engineering as well. We have an awful lot of facilities. We have subtractive type manufacturing that you see on the left for being able to machine an awful lot of items. We've got, electromechanical type systems that are dealing with lasers and light and optics and what happens there to use infringence patterns in order to figure out material property characteristics. We also have three-dimensional 3D printing that we would do. And we've got several variety of 3D printers that do exist. And we even have our large Foisy Center where we've got 30 or 40 of the printers that are just available continually for the students to use. If you like research and stuff, we offer research as well. As you see in the upper left corner, we've got Professor Yagobi, the short one, and he is going up onto the 0G or the Vomit Comet in order to study weightless type issues. And as you see in the upper right, that the grad students, they're having a very good time as they are looking at their apparatus while they're being weightless during the drops. And lo and behold, in the lower left, we've got our Professor Sarah Woden Schwartz, who has decided to relinquish looking at her project and is actually just having a good time being upside down. But what we offer, which is really good, is that up to 20 students coming in as freshmen, if you wish to get started doing sponsored type research, we will put you into one of our research labs and you can work there for the entire first year in a paid type position. You do have to apply for this, but it is available. We have a large amount of subtractive manufacturing where you can do several of your items. They're all very safe to operate. The Haas machining systems, work incredibly well. The detail that you can mill out and lathe and drill are quite detailed. This is a Stirling engine and you can build this entire thing as one of your projects. The only thing that you don't build is really the Pyrex dish that fits on top of it, but all the rest you do make. Again, our Haas machining systems, we have, state-of-the-art abilities to work with it. And we can brag as well that we offer a course, ME 1800. And this is just another item that one of the students machined for one of their probably MQP projects. A good thing to note about it is WPI offers these facilities. You are not required to take a course in order to use the facilities. That is, you do have to take a course in order to be competent and get checked off on the equipment. But if you want to work on your own project and your own time, you are free to use the facilities that we have, as this hybrid bike person was working on. So we offer a tremendous amount. Please try to ask any questions that you might have. We're more than happy to try to answer them. And I hope that you have a great time.
Awesome. Thank you. So we have our first question in the Q&A here. And the question is, what are the benefits of majoring in mechanical engineering versus a robotics major with a focus on mechanical engineering? So as I mentioned before, there's a lot of overlap between mechanical and robotics. It's a really common double major for people to have. If you are focusing more on the mechanical side of things, you would get a little bit more experience with the energy systems and the thermal and the fluid systems. Whereas on the robotics side, you would get more computer science and ECE, I believe. I don't know, John, do you have any other thoughts on those?
Yeah, no, that's great.
But yes, definitely a very common double major to have. Feel free to keep those questions coming while we wait for more questions. We have both Kelly and Dan here. They're both seniors. They're working on their major qualifying projects. They're on two different teams. And so maybe, and actually, I think both of their projects were student proposed projects. And so, Kelly, why don't we start with you? Can you tell us a little bit about your project idea, where you came up with it, and how's it going?
Yeah, sure. So my project is about eliminating microplastics, so really, really tiny plastics, from freshwater environments using a mechanical engineering approach. The reason we chose to make this a MQP as opposed to finding an MQP, which is also a very valid option, is because for my IQP, my junior year, sort of engineering, but also sort of social sciences project, I also did a project on microplastics, and I found it was something I was very passionate about. You know, I already knew that I was passionate about the environment, but then I found that this is a field that isn't very well studied, and I was really excited about finding out more about it and seeing what I could do to further reduce the effects on the environment.
Awesome. Thank you, Kelly. And Dan, you want to tell us a little bit about your project?
Yeah, so Professor Woden Schwartz is actually one of my advisors. And so my project, it focuses on the development of a VP Smart Shunt, which is a device for people with the disease hydrocephalus, which is a disease where a person can't naturally drain fluid from their brains. And so they have to have the shunt to drain the fluid for them. And currently the technology is very basic, and you don't know metrics such as intracranial pressure and fluid flow, which would be invaluable to know. And so we're looking at trying to integrate sensors into the current devices that would allow you to be able to track those metrics, and therefore would give indication on if and when this device would fail, which would prevent potentially life-threatening side effects.
Great, thank you, Dan. Looks like we're getting a bunch of questions coming in. John, you want to answer that?
Yeah, I'll answer the first one. Actually, I was going to type out the answer, but I hit the wrong button. So
Answer
let me answer it. So if you are with mechanical engineering, we do require that you complete 18 courses. We require 9 of those courses that we've already listed out, but you've got several other engineering courses, and we accept many of them that you might take, you know. And if you are interested in robotics, you know, we offer an ME RBE 4815, which is industrial robotics. It's a combined course. It's a cross-listed course. And in fact, between robotics and mechanical engineering, we've probably got 5 or 6 courses that are cross-listed amongst one another. Even if they're not cross-listed, you can still take at least 3 courses from any other engineering department and have it count toward your mechanical engineering. But cross-listing of courses with mechanical engineering is quite popular. In biomedical engineering, we probably have, you know, biofluids, biomechanics, biomaterials, biorobotics, and these are all cross-listed between mechanical engineering and biomedical engineering. So the cross-listings are A, quite high, but B, with mechanical engineering, you can still take several courses that are of an engineering nature, but not specifically mechanical engineering.
Right. Yeah, and I saw a question. I think someone may have answered it in text, but in terms of taking classes in other departments related to minors, we do have, in addition to engineering electives, they're generally just free electives. And so whether you want to do a minor in a different area, or if you just want to explore other areas and not do a minor, you have a lot of spots to take free electives in whatever course you would like to take. Let's see. How about, maybe I'll ask both Kelly and Dan to answer this one related to workload for this type of study. In terms of clubs and time management. I think both of you are involved in some clubs. Do you want to maybe start with Kelly? You want to talk a little bit about workload, time management, clubs?
Yeah. So I'll preface this with saying that I am not the best at time management. I never have been. I've definitely gotten better over the years, but it's still something that I need to work on. I think something that really helps is, you can like choose your own schedule and you can decide when to do things, but also, professors and clubs are generally, clubs are generally very clear about when things are due, when office hours are, when class times are, obviously. Yeah, I'm in, I think 5 clubs right now, which is too many for a senior to be in. But they're all great and I can't give any of them up. Yeah, I basically just, I don't know, what do you want me to say?
Well, actually, what are the clubs that you're in? I'm curious. I know you're in I know a few, but I didn't know about 5.
Yeah, so I'm in concert band, I'm in the Greenhouse Club, I'm in the Alliance, I am in and president of the Collab Lab, so that's the like student run makerspace, and I'm part of SMAS, so Society for Medieval Arts and Sciences, and that also counts for my PE credit because we do fake sword fighting.
That's awesome. Dan, how about you? Want to talk a little bit about time management, clubs, etc.?
Okay. I just will let you know there's a class getting out right here, so there might be some background noise. But so generally the time management isn't too much of an issue. Like I find a lot of times that like in clubs you are able to, a lot of them you can kind of not really go every single meeting if you have like extra work or have to study for an exam. Like right now we're going into finals week, so like it's a little more stressful, so a lot of clubs aren't meeting at all next week to give the students extra time because we all need that. But generally during most of the term it's not that bad of an issue, as long as you manage your time well, and kind of make a schedule of when you're going to do stuff. That's what works for me.
Great, thank you. I see there's a question here about teaching styles in the mechanical engineering department. John, you want to start and describe yours and I can go after you?
Let me type this answer.
Oh, all right, you're typing. I will answer. Sorry, I didn't see. Yes. So teaching styles, they vary from person to person. I am a big fan of project-based learning and flipped classroom, a lot of active learning. So I like students to be working on problems in class whenever possible, watching videos beforehand or reading content beforehand so that they're prepared to work in the classroom. I do really like to have projects in my classes, even if they're large enrollment classes. And so it gives people a chance to learn to work in groups, to learn to do peer review of each other. I think there's a lot of benefit to having projects in the classroom.
Yeah, I mean, I totally agree with that. In a lot of ways, I think that, what, Professor Woden Schwartz does is very similar to what I do. Most of the classes that I teach, I always try to have projects built in within them. Actually, Daniel is my PLA for an engineering experimentation course that I am teaching right now. So Dan is spending 10 hours a week working in the laboratory, with me for working on this engineering experimentation course. How is it that you measure temperature? How do you measure pressure? How do you measure, uh, what else do we measure? uh, Voltages, resistances, proximity, motion, and these other items. And the students do a project in there where they have to use and create their own device that uses multiple components. Several are making automatic plant waterers, where you go ahead and you have a sensor that detects how much moisture is in the soil. You've got a optical sensor that detects what the sunlight is. If the sunlight is bright, it will open up a window shade. If it's dark, it'll close a window shade. If you're low on water, it will go ahead and activate a solenoid or a pump and turn on and feed it water. But it's something the students design. Another popular one that they do are breath analyzers. So you measure alcohol content with an alcohol sensor. And when you try to make a breath analyzer, you have to make sure that it is a real one and not just somebody blowing air into the sensor. So therefore, the students design the breath analyzer, but they also have a humidity tester that they are checking to see, is it really a human breath that's coming out? What is its temperature? And then if the alcohol, let's say, limit is below some threshold, they might activate a motor or a sensor or a solenoid that will flip a switch, which will open up a latch and allow the car keys to come back out, just as a hypothetical item. In our lab, we use isopropyl or rubbing alcohol, but the idea is the same. You can use it for a lot of different items. But in other courses, we do projects all the time.
We have another question in the chat that I'm not totally sure how to answer in terms of, is there any difference between having a major in robotics versus a minor in ME versus majoring in ME and minor in robotics? Sean, I don't know if you have any thoughts on that. I think they're both good choices.
Or they are, I would really encourage you to consider very seriously a combined BS, MS instead. I think that it's more powerful for the student to get a bachelor degree in robotic and a master's in mechanical, or vice versa. And that's really just a preference. What do you want to do? And it's really important. You're going to live with this career for another 30, 40 years. So, please do something that you like. But the mechanical engineering and robotic engineering, the overlap is so very, very high. And I had answered to somebody else, but really about 30% of our combined BS, MS students, they actually complete the master's degree and the bachelor degree within the normal 4 years. And then a vast majority of the ones that do not do that actually complete it with one additional semester that you would do for doing that. Having your major with a minor is another very, very good option, but really it's what do you want to do? mechanical engineering is incredibly ubiquitous. So if you're undecided really what you want, you might consider thinking about the mechanical engineering with a minor in robotic engineering. However, robotic engineering is really 3 different departments working together for computer science as well as electrical engineering and mechanical engineering to make up robotic engineering. So it too has a great deal of flexibility. That's a tough one. There is no one answer to that.
I agree. I very much agree. Jessica asked in the chat if there was an engineering 101 type of class that introduces you to the discipline, like all the disciplines in engineering. We do have a course that's offered by the CDC. It's Exploring Majors. I think it might have a full name, but it allows you to learn about lots of different majors, not just engineering. And I believe it's only a 1/12 of a unit, so it's like a quarter of a class. And so students can take that to learn a lot more about different types of majors while they're taking more of their basic core classes. So we have a question here about sharing some non-engineering electives that you've taken or considered. Do you want to answer those live, Dan and Kelly?
Yeah, I can. I was just starting to write out an answer. Yeah, so we have a humanities requirement. We have to, do a certain amount of humanities. Don't ask me what number of humanities classes. Listen, I'm done with that. It's all done. I've got it. Which results in a capstone that you have to do, which is basically just another class, but maybe 5% harder, at least for me. So what I did for that was I did writing and literature and English, sort of all the same sort of thing. And I really enjoyed it. If I weren't, studying to be an engineer, I would be studying to be a writer though. So that makes sense. I've also taken, well, we have to take PE. Those have been pretty fun for me so far. I think I took a psychology course. That was pretty cool. Yeah, that's me.
How about you, Dan?
Yeah. So similarly to Kelly, we have to all do our humanities. I focus mostly in ethics and medical stuff, because that's an area that interests me a lot. And I did my capstone in humanities in bioethics. But in addition to that, I've also taken a US government class, and I'm going to be taking personal finance next term, which I'm looking forward to because that's going to be very useful in a few months once I go out into the real world. But there are many different classes you can take, such as art, music, you can explore other majors like computer science, writing, and other engineerings or physics, math. So
Yeah, that's great. In terms of your humanities requirements, there you'll take at least 5 courses, 3 of which will be in a depth area, so in one sort of theme. One will be breadth, so outside of that theme, and then another elective one, and then you'll do your capstone project experience, be it a seminar or a practicum. You can also, instead of that, you can also take a language for that requirement as well. There was a question in the chat about whether Dan and Kelly, if either of you got to travel for IQP. I know that the COVID year impacted at least Kelly. I'm not sure about Dan.
yeah, it impacted me too.
Okay, so yeah, because of COVID, we were not able to travel last year, as most schools were not able to. I can say that I've traveled as an advisor for IQP before, And it can be a really wonderful experience to go somewhere and work with a local community. It's a very different experience traveling for your IQP than the abroad experience at other schools, because you're not going and taking courses in another location. You're working with either a company or an NGO or a group in that local area and working on their project with them. And so you're really more hands-on working with the community. That's very different than an abroad experience that you would get at many other schools. We only have a few minutes left, and I think it might be worthwhile to have Kelly and Dan talk a little bit about why they picked WPI or what they really like about WPI. So Dan, do you want to go first and talk a little bit about either why you picked WPI or what you've come to really like about it since you've been here, or both?
Yeah, so for me, one of the main factors as to why I picked WPI actually was the project-based learning, because in high school, I personally was not the best test taker, but when it came to doing a project for a class, I loved it. I would have so much fun, and most of the time do very well. So that was something that really interested me, compared to a lot of other schools that don't have project-based learning. And in addition to that, my MQP, like as we said earlier, was student proposed. I proposed it. I generally actually had the idea back when I was in high school and I was applying to college and thought that's all it's going to be. It's just an idea to get into college. But once I came here, I realized the project-based learning would be a great opportunity to do that. And so I actually accomplished something that I kind of didn't really think I'd ever be able to do. So that was a really like huge point for me to do that.
Thank you, Dan. What about you, Kelly?
Got it. Yeah, so I do have to admit, part of the reason I came to WPI was proximity. It's really close to my house, and I had been here quite a few times for local robotics competitions. So I'd gotten a lot of exposure, the campus felt familiar to me. But it was also definitely partially due to how different it felt from other campuses. And it felt like, here as opposed to other colleges, which I looked at, it felt like maybe mechanical engineering won't be as difficult to get through, as much of a slog as at other colleges. I remember going to one college doing a tour, somebody asked about travel. They were like, oh yeah, we offer travel experiences to everybody. Oh, except for the engineering students, they don't really get to go. And I was like, well, that's no fun. Yeah, so definitely I guess I haven't been to any other colleges or been to any other college experiences, but just from my, very limited perspective, it doesn't feel only like an engineering college to me, and another thing, I also checked out, the humanities program, the band program, because I'd been very active in bands since like 5th grade, and I didn't want to have to give that up. And, they offered all of those creative opportunities for me.
Great, thank you. Liz, I don't know if we have time to answer this last question or if we should.
Yeah, you can answer the last question. Was it just that one question? I think it was, right? I
We're,
think real quick. That's fine. Go ahead, John.
Yeah, so we have a great resource. It's our CDC, which is our Career Development Center. And students take advantage of it all the time, but they have numerous postings for students who want to do co-ops. A lot of internships come in. They're posted there at the CDC all the time. But, I know that I'm, always, kind of like bombarded by students in order to approve, this internship going here, there, and everywhere that they are doing it. So there's a very, very active internship, which is available. We also offer, I know that I'm doing 6 different MQPs this year, which is really quite a lot, but 2 of them are sponsored. They're sponsored by the First Alert Company. So if you think about First Alert, you think of fire extinguishers, smoke alarms, and fire escape ladders. So we're doing a project on fire escape ladders. How can we improve the usefulness of a fire escape ladder, and also for fire extinguishers? So the students get to interact and work with the companies all the time in this paid type of sponsorship that the companies do in order to help facilitate. And that gives the students a chance to interview and work with a company to figure out, do I want to work there or not as a first type of job? And similarly, it gives the company the ability to do the same. So there's an awful lot of, probably about 20 to 25% of our projects are sponsored by companies. So you get that opportunity. And that is separate from the internships and or the co-ops.
Wonderful. Thank you so much. And I just want to say a quick thank you to Sarah, to John, to Daniel, Kelly. Thank you so much for sharing your experiences and also just taking the time to teach our prospective students about the mechanical engineering department. Hopefully this was helpful for a lot of you or all of you. If you have any other questions, feel free to send them to admissions@wpi.edu. And if you do have specific questions for either Sarah, John, Kelly, or Daniel, we can definitely field those questions for you. In the meantime, definitely check out all of our other virtual opportunities. We have sessions, we have on-campus opportunities as well. And thank you so much again for being here, and good luck with the rest of the school year, everyone. Hopefully see you all on campus.